Bismillahirrahmanirrahim. Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this particular video I'm going to solve some more questions, a few more questions from International A-Level Edexcel M1, and here we are particularly dealing with a past paper handout for chapter number 2, constant acceleration. Let's have a look at this question. This is past paper handout question number 16, which is IAL M1 June 2014, question number 2. So the question says that a ball is thrown vertically upwards with a speed 20 meter per second from a point A, which is h meters above the ground. The ball moves freely under gravity until it hits the ground 5 seconds later. The requirement of part A is to find the value of h. Okay, so first thing first, what we are going to do, we are going to make the sketch of all the information which we have up till so far. What we know, the fact is that we have a horizontal ground and point A is basically h meters above the ground. Okay, and from this point a ball is released upwards with an initial speed of 20 meter per second. All right, and after this ball will reach a maximum height at which the final velocity will be zero. At this point, at the maximum height above the ground, this ball will have a velocity of zero, after which the ball will change the direction of its motion. It will come downwards, okay, and it will hit the ground when t is equals to 5 seconds. All right, so our journey is started when t is equal to 0, and at t is equals to 5, the ball hits the ground. Okay, so the displacement for this whole journey would be minus h meter, because when we started from this point A and then we reached a maximum height, let's say this distance is x meter, and when ball comes over here again at point A, okay, so the displacement will be minus x, and x minus x will give you 0, and when t is equals to 5, ball hits the ground, so displacement will be minus h meter. Okay, so for this whole journey from t is equals to 0 to t is equals to 5, the displacement would be something like this: x minus h, meaning x minus h. This means that when t is equals to 5, so the ball is away from the starting point, but in the opposite direction. In the opposite direction. Okay, so the displacement for this whole journey will be minus h meter. Okay, and the initial velocity is 20 meter per second, since the initial speed is given to us. Okay, and acceleration will be taken as minus 9.8, because we are considering the whole journey. When the ball is going upwards, it is decelerating, it is slowing down, and when the ball is coming towards the earth, it is accelerating in the opposite path. Okay, so for this whole journey, we will have negative value for acceleration, which means that when the ball is going up, it is decelerating, and when the ball is coming down after reaching its maximum height, it is accelerating in the opposite path. Okay, so you need to be familiar with all of these concepts. Okay, so acceleration will be taken as a negative value, which is acceleration due to gravity, which is minus 9.8. Okay, and what we need to find, we need to find the value of h, and the duration of this journey is 5 seconds, because 5 seconds later ball hits the ground. Okay, so what we can do over here is that we can use s is equals to ut plus half at square. Okay, so we can say that minus h is equals to 20t plus half times minus 9.8 times t square. All right, so we just need to solve this equation. So minus h is equals to 20 times 5 plus half times minus 9.8. So this becomes minus 4.9 t square, and the value of t is basically 5. So minus 4.9 times 5 square. So just evaluate this thing. 20 times 5 minus 4.9 times 5 square. This is supposed to be minus 22.5. So minus h is equals to minus 22.5. Therefore, h will be 22.5 meter. This is basically the initial height of point A above the ground. So your answer to part A, the value of h is 22.5. So now let's move on to part B. It says that a second ball is thrown vertically downwards with a speed of w meter per second from A and moves freely under gravity until it hits the ground. The first ball hits the ground with a speed v meter per second, where v is an uppercase alphabet, okay? And the second ball hits the ground with a speed 3 over 4 times v meter per second. Find the value of w. All right. So what we are going to do, again, we are going to use a sketch. I'll bring the picture of this sketch on the next page. Okay. So I'll take a screenshot for this and I'm going to mark some points over here as well. Okay. So here is a sketch and I'll bring the picture of the question over here as well. So you can have a look at the information of the question again. All right. So what we know the fact is that a second ball is thrown vertically downwards with a speed w meter per second. So we have two balls now. Okay. First one is ball one, other one is ball two. So basically, first we had the sketch of ball one only. Okay. Ball one was released from A. It went up to a highest point above the ground and then it came on the ground when t is equals to 5. Okay. So what we can say is that ball one, because the information in the question is that the first ball hits the ground with a speed v meter per second. So let's just find the speed of the ball one by which it hits the ground. Okay, so we are going to find the value of the velocity. Okay, and initial velocity is 20. I'm talking about the first ball only. Okay, initial velocity is 20. Acceleration due to gravity is minus 9.8. Okay, and the displacement is basically minus 22.5 meter when the ball hits the ground when t is equals to 5. Okay, and we need to find the value of v. So v is equals to u plus at we can use. Okay, you can use any equation which is involving v over here because we need to find the final velocity, which will eventually tell us the final speed of the first ball when it hits the ground. So v is equals to 20 plus minus 9.8 times 5. Obviously, we are going to get a value of velocity which will be negative. Okay, because ball has changed the path of motion when it reaches the ground. So 20 minus 9.8 times 5. This is supposed to be minus 29. The velocity is minus 29 when first ball hits the ground. Okay, so the speed, therefore the speed when the ball 1 hits the ground is 29 meter per second. Okay, so now we know that the first ball hits the ground with a speed 29 meter per second and the second ball hits the ground with 3 over 4 times of 29. So 3 over 4 is multiplied by 29. This gives us 87 over 4, which is 21.75. So now we will have a ball 2. Okay, so for ball 2, now I'm going to make a sketch. What happens is that from point A, which is h meter above the ground, meaning 22.5 meter above the ground, what happens is that a second ball is released from here. Let's say this one is ball 2. Okay, this ball 2 is released vertically downwards with an initial speed of w meter per second. Okay, with an initial speed of w meter per second, and it moves freely under gravity until it hits the ground. Okay, so for the second ball, we are taking the downward journey as positive, meaning when it is coming down, it will accelerate. So we will take acceleration as a positive value, which is acceleration due to gravity, and it will have a positive value. Okay. And what we know the fact is that this second ball hits the ground with a speed of 3 over 4 times of 29. Okay, so just do the working for finding the value of 3 over 4 times 29. So this is 21.75. All right, so this is 21.75 meter per second. All right, and when this ball 2 hits the ground, it covers a displacement, it covers a distance of h meter, and the value of h is basically 22.5. So I'm going to say that the displacement is 22.5 over here, since we are taking the downward journey as positive. Okay, so what we need to find the initial velocity u, and then we would be able to tell the value of w over here. So I can use v square is equals to u square plus 2as. So 21.75 square is equals to w square plus 2 times 9.8 times 22.5. Okay, so obviously initial velocity will have a positive value because ball 2 is basically released over here from point A and it is coming vertically downwards. So the downwards journey is taken as positive. This makes sense or not? All right. As in the case of ball 1, the upward journey was considered as positive. So initial velocity was positive 20. So you need to have a complete understanding of these concepts before attempting the past paper questions. Okay. So keeping things simple and easy for you. So we have taken the downward journey as positive for ball 2. So you just need to solve this equation now. So just solve this equation. I'll do the working on the next page. So I can say that w square is equals to 21.75 squared minus what? 2 times 9.8 times 22.5. This is 441. So 21.75 square minus 441. So W square is basically 513 over 16. So conceptually, when square root is taken on both sides, so W will be equals to plus minus 5.6624. Okay, but we will have a positive value for the velocity as we have already discussed above. So therefore, W is equals to 5.66 meter per second. And since we are talking about the speed, so W is equals to 5.66 meter per second. W is definitely positive. This is the initial speed, which is 5.66 meter per second, correct to three significant figures. This is supposed to be our answer. Okay, we have taken our downward journey as positive. Okay, so this W will have a positive value because this is the initial velocity for ball 2. And ball 2 is coming downwards towards Earth and it is accelerating over the period of time. Okay, and the ball 2 is hitting the ground with a speed of 3 over 4 times 29, meaning 21.75 meter per second. So final velocity is 21.75. Okay, so initial velocity is also supposed to be a positive value. However, we are just talking about the speed. So even if you don't mention this plus minus over here, that is perfectly fine. I'm just trying to explain you when we take a square root. So we get plus minus both, but we will only consider the positive value over here. This is basically the concept behind this. So here you can just mention speed. Okay, that our answer is the speed, which is 5.66 meter per second. All right. So this was basically the question number 16 of the handout, which is International A-Level Edexcel M1 June 2014, question number 2. So now let's move on to the next question. So now moving on to the next question, question number 26 of the handout. Okay, this is IAL M1 June 2016, question number 1. Okay, so the question is saying that a car is moving along a straight horizontal road with constant acceleration a meter per second square, where a is positive, a is greater than 0, At time t is equal to 0, the car passes the point P, moving with a speed u meter per second. In the next 4 seconds, the car travels 76 meter, and then in the following 6 seconds, it travels a further 219 meter. Find the value of u in part 1 and the value of a. Okay, so here we have a horizontal motion. Okay, so what you can do, you can make a sketch for your ease. All right, so what's happening is that when t is equal to 0, the journey of the car is started, and after the start of the journey, in the next 4 seconds, okay, at t is equals to 4, the car has covered a distance of 76 meter. Okay, the car travels 76 meter, and then in the following 6 seconds, meaning from t is equals to 4 to t is equals to 10, it travels a further 219 meter. Okay, a further 219 meter. All right, because we are talking about in the following 6 seconds, from t is equals to 4 to t is equals to 10. Okay, so what we can do over here is that we can consider two journeys, and throughout this horizontal line, throughout this horizontal track, acceleration will be the same, because car is moving along a straight horizontal road with constant acceleration a. Okay, and here you have 3 points like t is equal to 0, t is equal to 4, and t is equal to 10. All right, so this is the thing, the acceleration for the whole journey will be the same. So first of all, if you consider the journey from t is equals to 0 to t is equals to 4, let's say this is stage 1 of your journey. T is equals to 0 to t is equals to 4 is the stage 1, and t is equals to 4 to t is equals to 10 is the stage 2 of your journey. So first of all, I'm talking about the stage 1. So what we know, the fact is that the duration is 4 seconds, acceleration is unknown, the initial velocity is u, that is also unknown, and the distance covered, displacement, is basically 76 meter. Since the car is not changing the path of motion, so distance and displacement is the same, and we don't know the final velocity even over here. But what we know, the fact is that at t is equals to 4, whatever the velocity expression would be in terms of u, that would be the initial velocity for the next 6 seconds. Make sense or not? Okay, so what I'm going to do, first I'm going to use this equation, v is equals to u plus at. Okay, so that I would be able to obtain an expression for the final velocity in terms of the initial velocity. I would be able to express an expression, I would be able to express v in terms of u. Okay, so v is equals to u plus a times t. Okay, so u plus a times 4. So I can just write u plus 4a. v is equals to u plus 4a. This is the final velocity at t is equals to 4. This will become the initial velocity for the journey from t is equals to 4 to t is equals to 10. The final velocity of stage 1 will become the initial velocity of stage 2. Okay, so v is equals to u plus 4a. Now, if we talk about stage 2, our initial velocity will be u plus 4a, which we have found earlier. Okay, and the duration for this stage 2 is 6 seconds, because we are talking about the next 6 seconds, we are talking about the following 6 seconds, and the displacement is 219 meter. Okay, and we don't know the acceleration over here. So what we can do, we can say that s is equals to ut plus half at square. So I can make an equation which is connecting u and a over here. All right, and I'm going to do the same thing for the stage 1 as well. So first I'm doing it for the stage 2. Okay, so 219 will be equals to u plus 4a is multiplied by 6 plus half into a into 6 squared. So 219 is equals to 6u plus 24a plus what? Half times 36. This will give you 18. So 18a. So 219 is equals to 6u plus 24a plus 18a. So this is 42a. So we have obtained an equation which is connecting u and a, where u and a are unknown right now. All right. Now I'm going to do the same thing for stage 1 as well, where I'll be obtaining an equation in which u and a are unknown. Okay, I'll be obtaining an other equation where u and a are unknown. So I can use the same equation. S is equals to ut plus half at square for the stage 1. So 76 is equals to u times 4, as we know that the duration of stage 1 is 4 seconds, plus half times a times 4 square. So u and a both are unknown. So 76 is equals to 4u plus 16 divided by 2 is 8. So 8a. So we have successfully obtained two linear equations in terms of u and a, where u and a are unknown right now. And for part 1, we need to find the value of u first. This means that you need to eliminate a over here. We need to eliminate acceleration over here. Okay. So I'm going to make a the subject. So a is equals to 76 minus 4u divided by 8. And I'm going to substitute this into equation number 2. So 219 is equals to 6u plus 42 times 76 minus 4u divided by 8. So 219 is equals to 6u plus what? 42 multiplied by 76 divided by 8. How much this is? This is supposed to be 399. Okay, so 399 and then minus 42 times 4 divided by 8. This will be 21. So minus 21u. Okay, so 6u minus 21u. 6 minus 21 is minus 15. So minus 15u is equals to 219 minus 399. Okay, so therefore u is equals to how much? 219 minus 399 divided by minus 15. So minus 180 divided by minus 15. The value of u is basically 12. U is equals to 12 meter per second. All right. So this is the value of u, and then we are going to find the value of a. So I'm working over here with black pen. A will be equals to 76 minus 4 times 12 completely divided by 8. All right. So 76 minus 4 times 12, this is 28. So acceleration is 28 divided by 8, meaning acceleration is supposed to be 3.5 meter per second square. This is supposed to be your answer. So value of A is 3.5 and the value of U is 12. All right. Alternatively, what you could have done, you could have taken this whole journey together from t is equal to 0 to t is equal to 10, where the displacement would be 76 plus 219. You can make an equation in that way as well, which is connecting U and A, where U and A are unknown. So whatever comes to your mind first, whatever clicks your mind immediately, just do it in that way and move on. All right. So for the purpose of this video, I've discussed these two questions. This was question number 26 and the earlier one was question number 16. Okay, so inshallah, I'll be uploading more videos. The link of the playlist for International A-Level Edexcel M1 past paper videos of mine, they are available in the video description. So keep that link saved. More videos will be uploaded in the same playlist. Thanks for watching. Until next time, Assalamu alaikum.